Every year, millions of birds embark on incredible journeys, traveling thousands of kilometers across oceans, mountains, and continents. But how do they find their way with such precision? Today, we uncover the secrets of avian navigation and the amazing adaptations that allow birds to travel such vast distances without getting lost. Bird migration is one of nature's most inspiring phenomena. Some species, like the Arctic tern, fly over 70,0 kilometers every year, traveling from the Arctic to the Antarctic and back. Migration allows birds to exploit seasonal resources, escape harsh weather, and breed in optimal conditions. But such journeys require extraordinary navigational skills that have fascinated scientists for centuries. These aren't just random flights. They are meticulously planned expeditions driven by ancient instincts. The routes are often passed down through generations, creating invisible highways in the sky that crisscross the entire planet. From the tiny ruby-throated hummingbird crossing the Gulf of Mexico to the bar-headed goose soaring over the Himalayas, each migration is a testament to endurance and precision. The sheer scale and complexity of these movements raise a fundamental question. How do they do it? What internal and external tools are they using to navigate a world that, to us, would require a GPS? Let's start with the most obvious guides, the sun and the stars. Birds use the sky as a natural compass. During the day, many species navigate using the position of the sun. But the sun moves across the sky, so how do they account for that? They have an internal biological clock, a sort of built-in chronometer, that allows them to compensate for the sun's movement and maintain a consistent direction. At night, nocturnal migrants rely on the stars. Experiments have shown that birds can recognize constellations and use them to maintain their direction. They seem to focus on the region of the night sky that rotates the least, like around the North Star, Polaris, in the northern hemisphere. This celestial map provides a fixed reference point, ensuring that even a subtle shift in star positions can guide them accurately across thousands of kilometers. But what happens when the sky is completely covered in clouds? Birds have another, more mysterious sense. Many species possess an internal magnetic compass that allows them to sense Earth's magnetic field. This incredible ability, known as magnetoreception, is still not fully understood, but scientists believe tiny magnetoreceptor cells in their beaks or eyes detect the field lines. This gives birds a mental map of both direction, like a compass needle pointing north, and their location based on the angle and the intensity of the magnetic field. This magnetic sense works in any weather, day or night, ensuring that birds stay on course even when all visual cues are unavailable. It's like having a built-in GPS that's always online, guiding them silently and flawlessly through the dark. Of course, birds also rely on more familiar methods. Just like us using landmarks to find our way around town, birds use them on a continental scale. Mountains, rivers, coastlines, and even man-made structures like highways and cities can serve as crucial signposts. Studies show that migratory birds have excellent spatial memory, allowing them to remember key stopover points along their route, places to rest and refuel before continuing their long journey. Younger birds often learn these critical routes by following experienced adults on their first migration. This process of social learning imprints the migratory map onto the next generation, ensuring the ancient pathways are not forgotten. Their brains are wired to create and recall complex mental maps of the terrain below. Beyond sight and magnetic fields, other senses play a vital role. Some birds, especially seabirds that travel vast distances over the open ocean, use their sense of smell to navigate. The ocean isn't a featureless expanse to them. Winds carry distinct scents from different land masses or even from areas rich in plankton, which can help birds pinpoint feeding grounds or their home colonies from far away. Other subtle sensory cues also provide navigational information. Birds can detect polarized light patterns in the sky, which are invisible to us but provide another directional cue, especially around sunrise and sunset. Some theories even suggest that they can hear very low-frequency sounds, called infrasound, generated by ocean waves crashing on a distant shore, giving them another way to see land long before it's visible. Finally, birds don't always travel alone. They navigate socially. Migrating in flocks is a brilliant strategy with multiple benefits. It allows individuals, especially young ones, to follow experienced leaders who know the way. Flying together also helps conserve a massive amount of energy. The iconic V formation is a perfect example of aerodynamic efficiency. Each bird, except the leader, flies in the updraft created by the wingtips of the bird in front of it, reducing wind resistance, and allowing the entire flock to travel much farther than any single bird could alone. This social dynamic also provides safety in numbers, helping to confuse and deter predators. Social learning within the flock ensures that even inexperienced birds can complete their first epic journey successfully. The incredible navigational abilities of birds demonstrate a perfect blend of biology, instinct, and learning. By combining celestial cues from the sun and the stars, an internal magnetic sense, a detailed memory of landmarks, and the power of social coordination, birds conquer immense distances year after year. Their journeys are a profound reminder of the incredible complexity and the wonder of the natural world, a world that continues to inspire our curiosity and the drive for discovery. They are the planet's ultimate travelers, and their story is written in the skies. Thanks for watching. If you enjoyed this journey into the world of birds, don't forget to like, subscribe, and hit the bell for more fascinating wildlife stories.